picture this.
Mhm.
You're dying for a coffee, right?
Yeah.
But paying with Bitcoin,
Yeah.
barista's cool with it, but then you're both just stuck like
Yeah.
waiting and waiting for this transaction to go through. Hours for a latte. I mean, come on.
Yeah, that's the reality of it.
That's the speed limit, basically, on a lot of these popular blockchains right now. And, you know, it's a problem Solana is aiming to fix. So today, we're diving into the Solana white paper.
Okay.
Think of it as their kind of grand vision for this, like super fast, super scalable blockchain,
Right.
and the real game changer they're proposing, something called proof of history.
It's fascinating, isn't it? Because, you know, most blockchains, what they do is they just spend all their time arguing about when something actually happens. Solana comes along and says, well, what if we, instead of arguing about the time, we just prove the order of events in a way that's like impossible to fake?
Okay, so it's kind of like, forget about syncing our clocks perfectly. We just need to know what came first.
It's exactly.
I'm already intrigued, but I need to wrap my head around this.
Yeah.
So what's the problem with how other blockchains are doing things?
Well, okay. Imagine, right, 1,000 people. They're all trying to agree on something. Let's say best pizza topping.
Okay.
But they can only shout it out like one at a time. And nobody's really listening anyway.
Right.
That's kind of what it's like for computers on a decentralized network when they're trying to agree on the order of transactions.
Uh-huh.
Slow, inefficient.
Ah, I see. So this whole like timekeeping thing, it's vital to making sure everyone's on the same page, but it also creates a bottleneck,
Totally.
which is what Solana is tackling head on.
Yeah, precisely. And they're doing it by taking this like radically different approach to time in a decentralized system, this
Right.
proof of history, which is really, I mean, it's a completely new way of thinking about consensus altogether.
So proof of history, how does it like actually work in practice? It sounds kind of almost too good to be true.
Yeah, well, you know, the white paper, it dives into some pretty ingenious cryptography.
Okay.
Imagine like a special kind of timestamping machine, right?
Uh-huh.
But instead of ink, it uses this thing, it's called a cryptographic hash function.
Okay, hash function. Heard the term before, but to be honest, always makes me think of breakfast potatoes.
Right. Well, these cryptographic hash functions, trust me, way cooler.
Okay.
Basically, think of a hash function like a digital fingerprint machine.
Okay.
You put some data in, let's say, you know, a whole Shakespeare play. It spits out this unique fingerprint. It's a string of letters and numbers. That's called a hash.
So every piece of data then gets its own like unique hash.
Exactly.
But how does that help us with the, you know, the order of events?
That's the beauty of it. So in proof of history, each new piece of data, each transaction, it's combined with the previous hash.
Okay.
And then it's run through this hash function again.
Got it.
So every event is linked to what came before it in a way that's like incredibly difficult to tamper with.
So it's like a chain of tamper-proof timestamps, each one linked to the next,
Yes,
creating this like verifiable history.
you got it. And here's where it gets really interesting. So the white paper, it talks about this thing called horizontal scaling. So instead of just one of these time stamping machines, Solana can actually have multiple generators.
Hold on, multiple generators all running like in parallel.
Exactly.
Wouldn't that create just a jumbled mess of timestamps?
It could, but it doesn't because they have a way of cross-checking and mixing their timestamps at regular intervals. It's like each one has like a slightly different perspective on the network's history, but they're constantly comparing your views to make sure they agree.
So it's kind of like a team effort
Exactly.
with each generator contributing to this single unified view of time.
Precisely.
That's brilliant.
And this is a key part of how Solana achieves such high throughput because you have multiple generators working together. It can process way more transactions per second than, you know, these traditional blockchains.
Which, as we were discussing earlier, is kind of a big deal in the world of crypto. But all of this relies on, you know, people actually trusting the system. What's stopping someone from just creating like a bunch of fake generators and wreaking havoc?
Right. And that's the beauty of decentralization.
Yep.
Right. So the white paper really emphasizes that proof of history, it relies on users like you continuously checking the system.
Wait, so I, as a user, I would be able to spot if someone was trying to like game the system.
Exactly. You'd be able to see if a generator was trying to like insert events out of order or create like a conflicting version of history.
Okay.
And the beauty of this cryptographic hash function,
Yeah.
any attempt at manipulation would be immediately obvious.
So it's like a system of checks and balances.
Yes.
But instead of relying on, like, a central authority, it's distributed amongst all the users.
Precisely. Trust, but verified. This approach to security, this is a big part of what makes Solana so innovative.
This is all incredibly clever, but even having, like, this, perfect record of time, that's only half the battle, right?
Mhm.
You still need to make sure that the transactions being recorded are actually, legitimate.
Right.
And that, if I'm not mistaken, that's where proof of stake comes in. Proof of stake, it's one of those terms you hear everywhere in the crypto world these days.
Right.
So in the context of Solana, like, help me understand how it all fits together with this whole, tamper-proof timeline thing we've been talking about.
Yeah, so with proof of stake, it's all about kind of aligning incentives, right? Imagine you're not just a user on the network, but you're also a validator.
Okay.
So you're someone who helps confirm transactions. With proof of stake, you're actually putting your own Solana coins on the line.
Interesting. So it's like I'm, vouching for the validity of these transactions, like with my own digital dollars?
Exactly, yeah.
Okay. But then what's stopping me from just approving everything, regardless of whether it's, legit or not?
Well, that's where things get, really interesting.
Okay.
The white paper, it calls this bonding.
Okay.
You're essentially like placing a bet on your own good behavior. So if you approve a block of transactions, right?
Right.
And then those transactions turn out to be fraudulent, like let's say someone trying to spend the same coin twice, you lose a portion of your stake.
Ouch. Okay, so there's a real financial incentive to, like, stay honest.
Exactly.
But I've heard there's, like, a potential issue with proof of stake,
Right.
called the nothing at stake problem,
Yeah.
where validators, like, they have no incentive to not approve multiple versions of the blockchain.
Yeah, sharp. Yeah, that's a problem some proof of stake systems face. But Solana, it has this, clever solution called slashing.
Okay.
If a validator is caught trying to like game the system, right?
Right.
By approving like conflicting versions of the blockchain,
Yeah.
a significant chunk of their stake, it's destroyed, like
Yeah.
completely gone.
Wow. Okay, that definitely raises the stakes.
Yes,
Makes you think twice about, trying to pull a fast one.
for sure.
But going back to, like, the white paper for a moment, how does Solana deal with situations where, the network gets fragmented? Like if there's, let's say, a temporary internet outage or, some other kind of disruption.
That's a great question, and that's where proof of history really shines.
Okay.
Because Solana has this, this objective way to track the order of events. It can make much smarter decisions when parts of the network get, temporarily out of sync.
So even in the midst of, chaos, this internal clock helps Solana keep everything straight.
Exactly. Yeah. Think of it like think of it like a team of synchronized swimmers.
Okay.
Even if one of them gets, briefly thrown off,
Right.
they can quickly regain their position because they're all working from the same underlying rhythm.
That's a great analogy. So to recap, we've got proof of history ensuring, this tamper-proof record of events. We've got proof of stake, keeping the validators honest.
Right.
But the white paper also mentions something called proof of replication. What's that all about?
Yeah. So proof of replication, that's basically Solana's way of ensuring data redundancy.
Okay.
Imagine like a library where every book is constantly being copied
Okay.
and distributed amongst all the librarians, right?
Right.
That's essentially what's happening with the Solana blockchain. And this data is replicated and verified across, the entire network.
Ah, so it's like a giant, like, decentralized backup system,
Exactly.
making sure that the blockchain's data is always accessible, resistant to, censorship or loss.
Precisely. And what's really cool here is how Solana incorporates this concept called streaming into proof of replication.
Okay.
Instead of verifying like large chunks of data all at once, which can be very slow and cumbersome, Solana verifies data in this like continuous streamlined fashion.
So it all comes back to speed and efficiency.
Exactly.
Seems like every aspect of Solana's design is really optimized for performance.
Absolutely. And that's what makes Solana stand out, in this crowded blockchain space. It takes proof of history, proof of stake, proof of replication, and it combines them to create this platform that's not only fast and scalable, but it's also incredibly secure, incredibly resilient.
It's really quite impressive. Well, as we start to wrap up our deep dive here into the Solana white paper, I'm kind of left with this lingering thought. If this technology, right, if it can create like this trustless and verifiable record of time for blockchain, What other applications are out there just waiting to be explored? Could proof of history revolutionize online voting, supply chain management? I mean, even just like how we track our digital identities. I don't know, the possibilities, they seem kind of endless.
Yeah, absolutely. The sky's the limit.
It's exciting stuff.